Hi everyone, a very good day to all of you. Today myself and my colleague Deepika will be presenting Istio Service Mesh, a primer. I have been working with Dell Technologies for last 6 years under server administration domain. Over to you, Deepika.
Hi everyone, I'm Deepika. I work in HPC domain. Today we are here to introduce you all to Istio Service Mesh. We shall first go through the agenda of today's session. First and foremost, we'll start with what is a microservice and how it evolved. So that covers the orientation part. And then we shall jump into the service mesh and get to know what are the requirements of the service mesh. After that, we shall go into the Istio, that is the service mesh, that today's topic, and get to know the W's of Istio service mesh, then the Istio architecture, and we'll understand the different concepts or components of Istio. Post this, we shall go into the core features which Istio offers. We shall brush on some important topics like traffic management, observability, and security. After this, we'll wrap up the session with a Q&A. Okay, so before we actually go into the service mesh, we shall first understand what is a microservice and why did this come into picture. So traditionally, the applications were built in a monolithic architecture. So if you consider any project, a project composed of modules that work together to form a single self-contained application. However, there are many problems associated with this kind of approach. So as the application grows and the development teams adds new code and new different capabilities, it becomes more and more complex. Testing becomes difficult and upgrading the application also becomes difficult. So as a result of all these things, reliability becomes a problem because if there is a bug in any of the module, it can impact the application as a whole. So in order to overcome these challenges, organizations have been transitioning from monolithic to microservice architecture. So now we all think, or we get a question, what is a microservice? So this microservice is a software development and an architectural approach. So this structures application as a collection of loosely coupled, autonomous, and independently deployable services. And these small business-driven services have clearly defined interfaces to communicate with each other. Also, this makes the application modular and easy to build and test. So it makes them efficient to deploy independently. So what is the benefit of this? What is the benefit of the microservice architecture? The complexity is actually greatly reduced because each microservice becomes a mini application. So when we say a mini application, it is much simpler to understand. Also, the speed of the development cycle is increased to a great extent because the development team is focused solely on that service, and also the services can be written once and used by many other applications. Upgrade cycles are also fastened up. The risk is reduced. And microservices can run on the cloud. They can run on a virtual machine. They can even run in a container or on a serverless instance. So the microservices are well suited to modern technology. And these microservices are also easier to scale and it is quicker to identify and resolve the bottlenecks. So these are the benefits which microservices offer. Okay, we understood what is a microservice. We shall just have a brief overview of how the microservices evolved. In 2011, Netflix introduced Netflix OSS. So this Netflix OSS is a set of frameworks and libraries that Netflix wrote to solve some of the distributed systems problems. A lot of Netflix OSS was written at a time where things ran on an AWS cloud and there were no other alternatives. A lot of assumptions about this heritage are baked into the Netflix libraries, and these things may no longer apply. In 2013, we saw the emergence of containers, that is using Dockers. With containers, things like service discovery, load balancing, fault tolerance could be handled, and we can take the advantage of the language agnostic infrastructures like builds, the packaging, deployments, and upgrades, stuffs like that. In 2014, to handle multiple containers and to orchestrate them, a strong platform called Kubernetes was introduced. So as we all know, Kubernetes is an open source container orchestration system for automating computer application deployment, scaling, and management. Next, we saw the emergence of Spring Cloud. This is mainly focused on Java application. It provides tools for developers to quickly build some of the common patterns in distributed systems. And in the year 2018, Istio came into picture. So this Istio is an open source service mesh, and this was introduced by 2018. We just saw how the microservices evolved. We shall see what are the challenges the microservices offers. So basically, there are many challenges, or we'll have to consider many design principles in order to transition to microservice architecture. There are like many challenges which I would like briefly go through. One would be the monitoring thing. So the traditional forms of monitoring and diagnostics will not actually align well with the microservices. Because in case of microservices, we would be more interested in how many or which microservice was traversed, how did it traverse, and how did the request come from and all, which is not the case in the traditional approach. So this monitoring becomes a great problem. Also, fault tolerance is a big challenge because it is important that individual services do not bring down the overall system. So that is a major challenge. And also, we also see that the engineering teams tend to spend more time in addressing these challenges rather than concentrating on the actual business goals. So like the suburbs around a city, the number of small services that are deployed seems to expand exponentially. So that becomes a great challenge. The exponential growth in microservices creates challenges around figuring out how to enforce and standardize things like routing between multiple services or between multiple versions, then authentication, authorization, encryption, load balancing. All these things becomes a big challenge. So one important thing is, so building on service mesh helps us to resolve some of these issues. So as containers abstract away the operating system from the application, these service meshes abstract away how inter-process communications are handled. Now, we went through the challenges of microservice. We shall see how this service mesh overcomes these things or how it helps us. A service mesh is a configurable, low latency infrastructure layer designed to handle a high volume of network-based inter-process communication. So in simple words, if I have to say, it is a dedicated infrastructure layer to make service-to-service communication fast, safe, and also reliable. So this service mesh is an extra layer of software we deploy alongside our cluster. This service mesh provides a consistent way to connect, secure, and also observe the microservices. Most service meshes are tightly integrated with an orchestration platform like Kubernetes. So you would actually think, okay, now when do I need a service mesh? Okay, I'm using the microservice architecture. Do I need a service mesh? Okay, the service mesh would be very useful in these cases. When we have a microservices written in many different languages that may not follow a common architectural pattern or framework, or when we are integrating third-party code and we want a common foundation to build on. Also, if our organization keeps resolving problems, especially in the utility code, we need service mesh. Also, if we have a robust security, compliance, or auditability requirements, then we need the service mesh. Now, we shall just have a look on what are the actual requirements of a service mesh. Now, if I have to use a service mesh, what do I expect from it? What things do I expect from it? There are a wide range of things. I would just brief you all out on a few of them. So we would expect service discovery mechanism from them. So this service discovery is how applications and the microservices locate each other on a network. We would also require load balancing. Load balancing refers to efficiently distributing the incoming network traffic across a group of backend services. We also need metric evaluation, then monitoring. This is to check the health of the system using different parameters. We also need the feature of rate limiting. So this rate limiting is a policy used to control the number of requests a service is allowed to handle within a given time period. Also, we need requirements such as canary deployment or A/B testing. So what is this canary deployment? This canary deployment or canary release is a deployment pattern that allows application to roll out new code or new features to a subset of users as an initial test. Let us consider an example. Now, when I deploy a new software version, we shift some percentage, say 10% of our user base to the new version, while maintaining 90% of users on the old version. So if this 10% reports no errors, then we can roll it out gradually to more users. If the 10% has problems, then we can roll it right back and 90% of our users will never see the problem. Then we have something called A/B testing. This is also known as split testing. So this is a process of showing two variants of the same web page to different segments of website visitors at the same time. And then we compare which variant drives more conversions. So these are the requirements which we would expect from a service mesh. Now we shall see why we chose Istio and what are the different features Istio offers. Mainly, what is Istio? This Istio is an open source project. It is a service mesh designed to connect, manage, and secure microservices. So this was created by Google, IBM, and Lyft. And the main advantage of Istio is that it does not introduce new functionality to an application's runtime environment. Basically, it requires zero code change. The main features which Istio offers are connect, secure, and monitor. So when we say connect, Istio enables services to discover and also to talk to each other. It enables intelligent routing to control the flow of traffic and API calls between services or the endpoints. It also provides a secure layer, that is, Istio allows us to secure communication between the services. It can enforce policies to allow or to deny communication. So, for example, we can actually configure a policy to deny access to production services from a client service running in development environment. Istio also offers monitoring capabilities. So Istio enables observability of our distributed microservice system. It often integrates out of the box with monitoring and tracing tools. So tools such as Prometheus and Jaeger can be integrated. Okay. Now, why do we want to use Istio? It allows automatic load balancing for HTTP, gRPC, WebSocket, and TCP traffic. So when I say gRPC, it is a modern open source high performance RPC framework that can run in any environment. This gRPC is roughly 7 times faster than REST when receiving data, and it is roughly 10 times faster than REST when sending data for the specific payload. And this is a communication protocol from Google. Also, Istio offers fine-grained control of traffic behavior with rich routing rules, retries, failovers, and fault injection. And this Istio is a pluggable policy layer, and it enables configuration API supporting access controls, rate limits, and also quotas. It also enables automatic metrics, logs, and traces for all the traffic within a cluster, including cluster ingress and cluster egress. So when I say cluster ingress, it is a collection of rules that allows the incoming traffic to the cluster. And when I say cluster egress, it is a collection of rules that allows the outbound connections or the outbound traffic. Secure and also Istio offers secure service-to-service communication in a cluster with identity-based authentication and authorization. Now we went through why we need Istio. A question might arise, who all can use Istio? So this Istio can be used by infrastructure operators to monitor traffic across clusters and regions. It can be used by platform engineers to build CI/CD tools. It can be used by app developers to investigate service metrics and behavior or debug during outages. It can also be used by security admins to enforce authentication and authorization policies. It can be used by the quality assurance team to mirror the production traffic to a test environment. So end-to-end, Istio can be used by everybody in the IT field. With this brief intro and overview of Istio, my colleague Binita will take you forward into the architecture of Istio. Over to you, Binita.
Thank you, Deepika. So I hope by now all of you are clear like why microservices came into picture, what were the challenges of microservices, and that's how service mesh came into emergence. And Deepika has already discussed about what is Istio, who it is for, what are the advantages of Istio, right? So now you have a pretty good knowledge about like what is Istio. But in order to understand more, we should be able to understand who is responsible for all these advantages that a service mesh provides. And in this case, what are the components in Istio that provides these amazing capabilities that a service mesh actually provides. So the diagram which you see in front of you, right, that is your Istio architecture. So if you see, right, all of you will be very familiar with what is service A and service B. It's nothing but your microservices. So in reality, an application will never have just one service, right? It will have plenty of services, at least the front end and back end. So what Istio does is the moment you install Istio, you will see that there is a sidecar proxy that will be attached to your microservices. Now, when I say attached to microservices, it is not going to write anything on your application logic. Okay, it just connects with that services. Now, if you're wondering why do you need a proxy? So all majority of the capabilities that Istio provides is coming via these proxies, like the load balancing or the traffic encryption, all those things which Deepika had mentioned. Also, if any service A want to communicate with any service B, not only within the microservices, if it is coming, if it is a request that is coming from the external world also, it has to go via this proxy. It has to first hit this proxy, and the proxy will verify whether this is a valid request or not. Once it is validated, then it will forward that to the corresponding microservices and it will address that request. So this service along with your proxy is called a pod. And this collection of all these pods, and each pod will have a service along with their proxy. That is called as data plane, which you see here. Okay, so one portion of the Istio service mesh is a data plane. The second half is called as the control plane. That is basically for configuring and management of the service mesh. Now, if you go to control plane, you will see there is a component called as Istio-D, which is the Istio daemon. And it basically consists of three components: pilot, citadel, and galley. Pilot is called as a driver of Istio. So whatever is the configuration that the user provides, right, that will be pushed to the proxies using this pilot. Okay. Now, who will push this configuration to pilot? That is done by galley. Galley is a configuration manager for Istio. Citadel will handle all the security aspects with respect to Istio. That is, certificate management, key management, all those things are taken care of Citadel. So the control plane in Istio consists of the Istio daemon, which will have pilot, citadel, and galley. Apart from this, so we have told about, we have microservices, we have pods running. Now there is two more things that you have to take care of. That is the ingress and egress traffic. Deepika has already given a brief intro of what is ingress traffic. Any external traffic that is hitting your microservice is called ingress traffic. And if you take any application like Amazon or eBay, you will see that, there is some place at some point of time they have to exit from that app, right? like payment service, where you have to hit an external service, banking service, right, in case of payment. So those are called as egress traffic. And the one which comes to us is called as ingress traffic. So I have briefly told you about all the components. We will be digging deep more in the coming up slides about these components. So my service mesh essentially consists of a data plane, a control plane, along with the ingress and egress traffic. Now let's deep dive to what exactly is a data plane. So I said data plane is nothing but your service along with your proxies. Now, when I say about proxies, these are set of intelligent proxies called as envoy proxies, which are deployed as a sidecar. This is called as sidecar pattern. Now, Envoy is again a third-party open source tool, but majority of the feature which Istio provides come from these Envoy proxies. Okay, and to tell about the perks of Envoy proxies, if you see, this is a C++ based L4 L7 proxy. It has a very low memory footprint. It is battle tested at Lyft, so it runs with 100 plus services. It can actually 10K VMs can run at the same time, and it can address 2 million requests per second. Now, and this is, as I said, this is a open source third-party tool. So many a times people wonder, okay, if that is the case, then why do I really need to integrate Istio? Because Istio comes along with Istio's itself components, right? Well, the answer is yes. You can have your sidecar proxies as Envoy without installing Istio. But the catch here is, this is a low-level tool and it can be directly consumed for engineering. Plus, as an engineer, you need to sit and study like the different terminologies and the APIs that Envoy proxy has if you want to integrate it to your services. So that is a complication that Istio hide. And when you just install Istio, it just injects the sidecar proxies. Also, these proxies mediate and control all the network communication between the microservices along with mixer. So the diagram which I showed you as architecture, right? Earlier from Istio 1.5, that is architecture. But prior to that, there was a component called as mixer that was used for telemetry. But now that the telemetry collection is handled by this Envoy proxies itself, that has been deprecated. The mixer has been deprecated from 1.5 onwards. Now, if you see the animation below, you can see that service A want to send a request to service B. What happens? It first hits a sidecar container of service A, it validates it and forwards a request to sidecar, the service B sidecar container. Again, the Envoy proxy of service B will validate and then forwards a request to the service B, and it addresses that request and that result is given back to service A. So this is how the communication happens between two services in a service mesh. Now, you might be wondering like, okay, there is a proxy, but what exactly does the proxy do? Even though we have discussed a few. So before Istio or before service mesh came into picture, the diagram which you see, right? Imagine you have a container where you obviously have your services up and running because that is your business logic, right? But apart from that, the developer had to concentrate on writing logic for discovery of other services, load balancing, resiliency, tracing, metrics. And imagine he had to write the same for all the services. Okay. Now, if in case one of the logic inside the service go for a toss, there are very high chances that your whole application might go for a toss. So it used to be pretty difficult. And remember, whatever you write, right, it should be consistent and concurrent across all the services. Otherwise, there will be issues with, this is not compatible and all those things will come into picture. Now, once service mesh, or in this case, Envoy proxy had come into picture, the developer can just concentrate on writing the application logic. He or she doesn't have to worry about writing logic for this discovery, load balancing, tracing, etc. So that is the main advantage your sidecar Envoy proxy brings to the table. So now we have talked about the data plane. Now let's see what is a control plane. Control plane manages, controls, and supervises the network of microservices. So as I said, from 1.5 onwards, there is Istio daemon, which has three components: Pilot, Citadel, and Galley. Now, Pilot configures all the Envoy proxy instance deployed on Istio service mesh. Pilot provides service discovery for proxies, and it is a core component for traffic management. Pilot fetches configurations from Galley, as I said before, and lets you specify which rules you want to use to route traffic to your proxies. It also helps you to configure service recovery failures such as timeout, retries, circuit break, etc. So that was the main advantage of Pilot. Now coming to Galley. Galley is, as I said, he is a configuration manager and also responsible for the distribution of these configuration. Galley insulates the rest of the Istio components from the underlying platform. In our case, we were using Kubernetes. Galley ingests the user supplied configuration and validates it before distributing to the pods. Now, last but not least, it's Citadel. As I said before, Citadel handles all the security aspects. It provides strong service to service and end user authentication using mutual TLS, built-in identity, and credential management. So that's pretty much about the architecture of Istio. Now, when coming to the core features of Istio, right? Istio has plenty of features that it supports. But while we were doing our POC or hands-on, right, what we understood is these three are the top core features which Istio has. One is traffic management, one is observability, and one is security, which is definitely the hot topic nowadays. So let's deep dive into each of this. Traffic management. So why do you think traffic management is important? So remember, I was telling that, generally your application is just one or two services. It will have hundreds of services that is up and running, microservices that is up and running. So you always need to understand what is the network and interactions between these services. Also, once you have understood the network interaction, you need traffic inspection, that is taking individual requests and processing them. Other than that, you also need, Istio provides a lot of tools for automation, and also this helps with traffic management. When I say traffic management, there are a lot of granular policies that you can specify in Istio. Other few features of Istio provides are safe rollouts with traffic splitting, client-side load balancing, timeout, retries, and circuit breaking. So, one of the interesting features that Istio provides was canary deployment, right? But to understand canary deployment, we need to understand three things. One is gateway, one is virtual service, and one is destination route. So irrespective of you have a canary service or not, if you have an ingress and egress traffic coming in, you need to have a corresponding ingress and egress gateway. Now, when I say about gateways, it describes a load balancer operating at the edge of your service mesh, receiving the incoming or outgoing HTTP TCP connections. Not only that, it also gives specifications like describing a set of ports that should be exposed, the type of protocols to use, whether it is HTTP, TCP, or WebSocket, then the virtual host name to listen to, etc. So whenever we say about a gateway or any sort of proxies, it's always Envoy proxy in Istio's case. Once it has reached your ingress and egress gateway, then it will go to your Istio service mesh network, like the picture shown here. Now, so you have actually some external traffic some incoming traffic have come to your service mesh. That's where you had hit your ingress gateway. Now, once you have reached there, then the virtual service comes into picture. So remember, she was telling about, my friend was telling about the canary deployment where you want 10% of the users to go to the new version and 90% should go to the old version. So that is where virtual service comes into picture. Any traffic that is hitting here, right? Based on the rules that you have written, it will decide which destination it should go, whether it should be the old destination or whether it should be the new destination. Now, once the traffic has, this has been decided, like which destination to go. It is a destination rule that plays, importance, like out of, you have reached a destination. Now that destination will have a subset of or different versions of that destination only. Like in this case, reviews v2 can be, there will be multiple subsets of the same. And then destination rule will tell you, or will tell, okay, from here, it should reach to the ultimate point, reviews v2.1, something of that sort. So a virtual service is nothing, but it defines a set of request routing rules that can be used to distribute traffic to the different destinations in your service mesh. And the destination rules will come into picture. Those are the rules that will apply to a traffic after they have been routed to a particular destination by the virtual service. So from the subset, it will choose which set it should go to. So that is pretty much about, traffic management. But even though I said pretty much, it offers, it's a lot more. The second one is observability. Now, when I say about observability, while we were just doing, some hands-on exercises on Istio, we were trying out different tools that helps in observability. So overall, if I tell you the picture of observability means telemetry for every service, logs for all the traffic, you'll get different varieties of service graph, workload graphs, etc. But the most interesting tool that we have found was Kiali. So Kiali is a management console that has been made for Istio. And if you're wondering what exactly Kiali does, it tells which microservices are part of my service mesh, how are they connected, how are they performing, and how can I operate on them. So these, not only this, so when you're actually working on Kiali, right, if you're not very much comfortable with writing the Kubernetes YAMLs and all, the things which I was saying, right, the virtual service, destination rules, or gateway creation, all these things can be done using this Kiali console. Like, you just have to tell what is the percentage and what are the services that you want to, and it will automatically generate a YAML file. So it's a much more handier and easier tool to use. And it has plenty of, workload graph, service graph, you can add a lot of animation to your request. And, it says which service is down. So all these things, beautiful features can be seen using a Kiali console. And it's from us, it's like a go-to tool for Istio. The second one, many of you will be very familiar with this dashboard. It's a Grafana dashboard. So again, Grafana is an open source tool that basically actually helps in monitoring the health of your service mesh. As you see, it can give you more insights about the memory, CPU, and disk consumption of your particular services. Last but not least, we would like to call out Yager. So I was telling about the overall service mesh and, overall connections between these services, right? Yager comes into picture when you want to do a root cause analysis, especially it is useful for developers, right? Where they want to actually check this individual request. They have to take up individual request. It's also very good in, it gives a good lot of information about distributed tracing and also troubleshooting individual request. So it will tell you, okay, for one particular request, how many hops across different services it took, how much time did it take or did it spend in each of these services. So these type of things will help you in bringing, in making your product better by, verifying like what went wrong or why it had spent so much time on that particular service. So these type of small things you can find with the help of Yager. So we have already covered the traffic management and observability. Now, last but not the least, security. So you might be wondering, like, configuring TLS or HTTPS for our service is a pretty straightforward thing, right? You can do that. But, there are a few questions that you need to ask yourself when you're doing that. Like, for examples, do we have the right certificates? Are they signed by the certificate authority that your clients will accept? Are we enabling the right CIFR suits? So there are a lot of questions that you need to ask yourself before, start writing about your security HTTP, configuring your HTTP TCP service. So that's where exactly Istio comes into picture. Istio has a lot of things that make sure that, you have encryption in transit, service identity, authentication, authorization, all of these are taken care by Istio itself. Now, how does it take care? For that, we need to see the security in Istio involves multiple components that you can see in the diagram. So first of all, it has a certificate authority. So inside Istio D, you can see something called as certificate authority. Now, certificate authority is mainly comes into picture for key and certificate management. Then you have a configuration API server that distributes to the proxies authentication policies, authorization policies, and securing naming informations. Apart from that, the sidecar proxies that you see over here, right? These sidecar proxies and perimeter proxies, these ingress and egress perimeter proxies, work as policy enforcement points to secure communication between the clients and the server. And the set of Envoy proxies extensions to manage telemetry and auditing also. So this is what I said. Even though we call it as a sidecar proxy, there are a lot of things that it brings to the table. So now how a user is validated? User is validated using JWT, that is JSON Web Tokens, along with TLS and MTLS, mutual TLS. So these JSON Web Tokens not only authenticates the user, but it also specifies what all claims the user has on a particular service. Okay, so this is the overall picture of how Istio security takes place, and most of them are actually handled by Citadel. Now, when we say about security, it is always very difficult to just, make sure that, okay, everything is up and running, right? That's not easy. So Istio has these two modes of, mutual TLS. One is permissive and one is strict mode. I hope people who have worked in Linux, AC Linux background would have heard these terms, permissive and strict. So here also the logic is same. So if you are migrating to Istio or service mesh, right? It will be very difficult for you to know what service is doing what, and it's very difficult to just migrate just like that. So let's say you are in that migration process. So you will have some services that are in non-Istio namespace and some of them which are in the default namespace. So when a request comes from non-Istio namespace, if you have kept the mode as permissive, then your request will be addressed. Okay. But if you are coming in a strict, if you put your mode as strict, then unless the request come from a default Istio namespace, your service is not going to be, your request is not going to be addressed. So depending upon where you are at the point of time, you can switch between these two. That is the permissive and the strict MTLS. So that brings to the end of the session. So let's just have a quick glance on what are the key takeaways for the session. Istio brings tools to the DevOps and SRE to manage network consoles. Also, it helps dev teams, letting them focus on delivering the business value. Istio tackles microservice concerns in a uniform and a declarative way. We have already discussed like what are the drawbacks of microservices and how the service mesh, helps in overcoming those challenges. I hope this talk has enabled all of you with the core features of Istio technology like traffic management, security, monitoring, and observability, and also to understand what is the overall Istio architecture.